Hi, I'm Edwin D'Souza. I'm the Senior Director of Product Marketing at MySQL. So this conference is about MySQL developers and MySQL DBAs. For developers, we have the father of PHP. What more could we get, right? So next we have to think about who do we get to speak for and about MySQL DBAs. So I think we have a fantastic MySQL DBA next up. The best way to describe Paul Tuckfield is in his own words. And this is what he was saying to some of MySQL's engineers yesterday over lunch. What do I know about anything? I was just the DBA at PayPal, and now I'm just the DBA at YouTube. And before you think, man, they must have hundreds of DBAs at YouTube, there's only 3 guys at YouTube who make it all happen. So, with that, let's actually get Paul up here and to tell us about his secrets and lessons learned.
Okay, good. I didn't actually say that. I just said I'm just the DBA. But I guess it comes off better that way. Hoping to get a keylogger on there right now. So yeah, when they said, well, this is pretty much what I'm going to try to do. I hopefully will be able to, regale you with some more stories of some of the things that I've done on YouTube. My sincere hope is that there's at least a few things I can pass off on to somebody out there. There should be somebody out there who's trying to make their database faster or bigger or whatever. And hopefully I can give you something you can use as well. As he said, well, I guess you didn't say exactly this. I've been a sysadmin for a long time, 25 years. Not exactly right. That's counting college, right? So in college, of course, okay, here's my first old-timer story. I called myself a sysadmin, but what I really did is I sat around and played Rogue, which is a text-based video game on a Batch 11750. Whoa. And that's the reason I know the VI navigation keys. VI users out there? All right, good. Emacs? Okay. Sometimes I think that has a lot to do with whether you're a sysadmin or a developer, but so here's my VI gang sign. So yeah. After a while, I started doing just about exclusively Oracle, but through all that time, I did a lot of low-level sysadmin stuff like disks. I'm always very obsessive about disks and how they're laid out. I guess, pretty good reason. So I came to be a DBA sort of from the other angle. A lot of people sort of are developers and then sort of have to do DBA stuff. I guess I was a sysadmin and sort of came the other way. And I think that's probably has a lot to do with why I sort of gravitated and sort of self-selected for a lot of these high-end scalability kind of gigs. I've been a MySQL DBA. I say MySQL. It shows my Oracle background. That's sort of MySQL. Anyways, I've been a MySQL DBA for 8 months because I was lucky enough to have some friends at YouTube, and I started at YouTube, and I've been taking it easy ever since. Kidding. Working pretty hard. Everybody's working hard at YouTube. So I just want to get one important thing out of the way. I think we did a lot of good things for scalability for MySQL at YouTube, but YouTube serves video, so I don't know if you guys knew that. And so I was trying to illustrate here with this fancy picture is that there's a heck of a lot going on to serve these videos. Even still, I suppose the web app that looks familiar to just about every website, I suppose, is probably pretty big in comparison to a lot of places. So again, hopefully I can impress you and give you some fun tips. But I just want to illustrate the point that I did the build up. I missed the big build up. Okay, I'll go back. So get your cameras ready because I'm going to tell you the 4 reasons that YouTube scaled as far as it did. And, there's 4 reasons. So if you're building your website that shows videos of who isn't, hire these guys and you're all done. Brilliant guys. Bradley, I guess going from the left, Bradley Heilbrunn, great sysadmin. Mike Solomon, fantastic programmer. All funny guys, all of these fun guys to work with, super dedicated. Kungo, another fabulous programmer, always finds good luck, doesn't matter where it is in the site. And Colin Corbett, guy who built an immense network, basically with his own 2 hands. There's more people working at YouTube now. On the day this picture was taken, that is literally true that these guys, you know, a lot of people built YouTube, but these are the guys who made YouTube big and fast up to that day, and really the biggest line share past this day. This picture was taken right after I started on YouTube. It's in a place in Palo Alto called The Creamery. It's like a hamburger joint, right? And so they have this sort of special thing, you know, being in the middle of Silicon Valley, I guess. They have a special thing called the Bubbly Burger, which is you get a hamburger and a bottle of Dom Perignon champagne for $150. So this is the day, right after the day that YouTube served 100 million video views in a single day. I was actually there. I've known these guys for a while. We're all actually PayPal guys. I'm sitting off to the right there out of the picture because I didn't scale YouTube up to that point, and so even though they were nice enough to say, yeah, take a picture, I sort of stay out of the picture. But great guys, and I just want to reemphasize. I think that a lot of people think that technology is going to be what scales a website. I think it's the people. I guess I better keep tapping because I got a screensaver on. So if you want to forget about the people, I suppose using technologies. I guess having been a DBA, I think DBA is a foreign concept to a lot of in the MySQL world. I think it's getting more common. But in the things I've done all through the .com boom and some big places, I tend to view myself as sort of like a goalie or whatever. There's a lot of smart, hopefully if I'm lucky, I work with a lot of smart people, and I am at YouTube. They're working super hard to make everything as good and fast at the application level as possible. When all those things fail, that's when I'm trying to fix it on the back end, right? So I think one of the biggest things that made YouTube scale was Python. That is because a lot of things I was at in the past, I had nothing to say other language, but things are familiar with anyone who's used a scripting language. You can manipulate some very powerful concepts and objects and things that would have taken years and had millions of bugs in the past. And I think Python probably stands out amongst scripting languages. It's a good balance between it covers a lot of the sort of computer science, object-oriented structure. Well, I shouldn't talk about that. The places I've been before, they're doing these things in C++, whatever, brilliant programmers, but they couldn't. You just couldn't do some of the things that you could do with scripting language like Python. And so that's a very big reason that the database of YouTube scale is Python. Next one I would say is Memcache. You talk to some of these great programmers, they wouldn't really say that there's anything special in particular about Memcache, but I just want to point out that the fastest query on a database is the one that you never sent to the database, right? You didn't have to hit the database, you just got the answer. So in a big way at YouTube, and I think in a lot of other places, some smart programming can avoid doing database hits that you don't have to do otherwise, and that's why Memcache is important. I think a lot of these guys, they tell me that they gnash their teeth trying to get Memcache to work in some cases, but it's a good thing, and the fact that we're caching outside the database is huge. Last thing, and of course probably the most interesting people here, I hope, because that's what we'll be talking about for the next 40 minutes, is MySQL replication. Probably pretty familiar to all of you. That's the one thing that we use to scale databases at YouTube far more than anything else. And we took replication probably a lot farther than anybody really wanted to or should have. But we had, choices were, scale, or do nothing and fall over. So we pushed replication very, very far, and until recently when we were able to do something a little bit more sophisticated, we should scale even farther. I'm not allowed to talk about numbers, but these are the public numbers that are available. We now have 100 million views. sometime in September. I think it actually happened in August of 2006, or was it July? Anyways, probably get fired for that. And so I can't tell you what we're doing now, but if you want to extrapolate, feel free. I can either confirm nor deny that linear extrapolation will work here. So there's challenge number one. That was my second look at YouTube. Just to recap, when I arrived, this is about what it looked like. We had essentially a database that was running the whole site, and what amounts to click tracking, who clicked that one video when, was also streaming to a MySQL table in a separate database. MySQL is beautiful for that. It's still working very nice with some small changes since then. And we haven't had to worry about it. And of course, on that day, it's inserted 100 million rows in one day. And that's about, I think we peaked at about 2,000 a second. And everything else, the things you might be familiar with on YouTube, if you do anything besides watch videos. Some people wonder why you want to do anything but watch videos on the site, but there's an awful lot of things you can do, like click favorites and comments, all sorts of metadata that people have built up. All that other stuff was, until very recently, and of course on that day, it was all being written to a single master, being replicated to a lot of slaves. And of course, the slaves, since our application, like a lot of others, does far more reads than writes, it's all working, it's all good, life's good. You try to balance all the reads across all these replicas. There's far fewer writes, even though it's still a lot, going into this one database. And you got 5 databases all sorted with reads. Of course, as you saw from that graph, we were going pretty fast. We started, so basically the whole story here is that we relied on this setup to serve our traffic, and anytime the replication starts to slow down, you're screwed, because it's hard to write an application that understands when I just got done inserting a new account, say, into the master database, and then you go to refresh, that user goes to refresh a page, and this page is being served from one of these replicas. Where's my account go? It didn't get to the replica in time. If replication is going slow, it all goes to hell. The user refreshes their page. I had an account a second ago, and now it's gone. And it gets even worse, because if the replicas are not replicating at the same pace, maybe the account's on this one, but it's not on this one, so they refresh the page. Oh, there's my account. They refresh the page again. It's, oh, my account's gone. So it can get really bad really fast if replication is not going fast. If it's going fast, well then life is good. It seems like you got this infinitely scalable database. But boy, keeping the replication going fast, I don't know, anybody else doing this? Have trouble keeping it going fast? Anyone? No? Okay, well that concludes my talk. But that's mostly what we did. You'll forgive me, hopefully. Anyway, so what was this page about? One of the first important optimizations was, I couldn't go, came up with the idea of, we had a lot of replicas at this point, they're all lagging, by a lot. We tried a lot of things. One of the things that worked really well was separating certain pages to use certain replicas. Out of all the replicas, you send certain pages to these ones and certain pages to these ones. We tried a bunch of, mostly mental experiments, but we tried, what if you just put one table on each of these replicas? And then it only has to replicate at one table. We somehow black hole the rest. We couldn't have the black hole engine to work, incidentally. But I guess it doesn't really apply here. That doesn't work, right? Because that problem with the pages being refreshed with different replicas, where one's farther ahead than the other, it's even worse if you try to do with one table on it. Because now, not even the tables don't even match when you're trying to join them, right? And you have to restructure everything. That didn't work, a bunch of other things. But if you send the whole page, and let the whole page be built from a certain replica, a couple of really good things happen, probably work for you too. It caused greater cache affinity. It's probably the biggest thing. And so they immediately start performing better because there's a certain working set in this one, a certain working set in that one, and you're doing a lot less physical I/O, and replication gets faster. So probably something you could do on your website. Another very important thing is probably maybe like us, the most important page on our site is that watch page. If you click on watch page, you want to see the video. And all that other stuff, we grind our teeth sometimes us developers and system and DBA types. But it's important to give a quality of service to that watch page because most of the people in the world are coming to just watch that video. And if you're going to make one thing go fast, you might as well make it that watch page. And so you can favor the watch page by doing this, and that's probably something that can apply to other videos too. So that got us a little bit farther. About that time, we were trying to standardize. There had been a lot of different types of hardware that were sort of hardware upgrades before I arrived. There were a lot of different configurations, and that caused a lot of problems for one system and trying to run the whole place rather out. And also, it wasn't any good. It was bad at a lot of levels, and we started to try to standardize on this hardware. Good hardware, good vendor. Probably more disk drive. Maybe it's more disk drives than a lot of people are used to. Haven't been a long time to I love more disk drives. I'll talk about that later though. But yeah, it was some of my first adventures in my first few weeks there. The problem was that these new boxes that we needed desperately, and we were rolling out very fast, we couldn't just not use them. They were crashing, and the MySQL was crashing. It's not fun to see the word corrupt in the error log, but that's what was happening. And of course, I lived in MySQL. Fortunately, Kuhn had a lot more experience. Taught me a lot in those first few weeks. But we found ourselves, doing what you hope you can do with replicas. If one of the replicas fails, of course, here's my fancy visual here. It fails. What do? You don't worry about it when the replica fails because you got a lot of replicas and there's just one less. And nobody got hurt. The thing comes back. One of the things that sucks though is I found out in the first few weeks is that InnoDB doesn't really recover quite that fast. I should mention whenever I'm talking about MySQL, I mean InnoDB. That's something that somebody pointed out to me earlier. So when I'm talking about MySQL is this, MySQL is that, I'm usually saying MySQL InnoDB. Anyways, InnoDB doesn't recover very fast. When the thing it does have durability of transactions, but boy, when the thing crashed, we had so much stuff in cache. It was a nice big cache that it took hours for InnoDB to recover the cache. And so on a replica, well, we're down on replica. But when it happened on a master, boy, those first few times, you're sitting there sweating bullets with a word corrupt in the error log, waiting to see if InnoDB would finish recovering the master database. We had replicas. We could switch to the replica, but did you test that? Are you sure that the replica is the same? And when you copy, and if all these, you got backups, but how many backups can you restore in 8 hours, 10 hours, 20 hours? When you go to switch to the replica, are you sure you didn't, are you sure you did those commands right? Are you sure you didn't miss the place in the bin log? Are you sure you aren't going to break the replication for all your other replicas now, and then now you just screwed your last copy? Or now you're going to go to the backups, take 24 hours, did you test the backups? When you go to recover the back. Anyways. That's what I've been doing for 15 years. But it was even worse on this day because I didn't know what the hell was going on. I learned pretty quick. I think that was the one time I saw Kuhn hesitate about a few things because we knew how to do the situation. Anyways, we got real good real fast, and we saw a lot of failures. This is my fantastic explanation of how you. We got really good at fixing, at switching to the replicas and doing it fast and doing it reliably. I think the sort of the takeaway was that replication played a big part in fixing that problem. When you tried it, to get to the point of the story, we realized it was a controller and a certain combination of hardware. I still have trouble believing it because you'd think that the thing would just fail all the time, but it didn't. It would run for days and fail on one block. But we switched controllers. There's nothing against that one controller. I think it apparently had to do with a combination of a lot of different permutations. So we had to trial those permutations, and we could do that with replicas, right? We could trial these different things. I quickly, as fast as I could, I went back to some of the older hardware and upgraded it. And we got the master stable for a very long time, and then we iterated on all the replicas, trying different things on different replicas. The fabulous thing about replications got to the real problem. Yeah, he said 20 again. So we change the title of this lessons. I'm not much of a teacher here, but things you guys probably already know. Go replication. But one of the most powerful things about it, again and again, is the ability to, if you can keep the replicas going fast enough and you're serving traffic off the replicas, it's a very powerful place to test things that I couldn't really do at places I've been in the past, with Oracle in particular, and big financial sites like PayPal. You can't just try a clean change and test it. But with, you got dozens of replicas, you can do a very good test where you make a change on this replica, and you don't make a change in the other replica, and you watch the graphs. Hey, that was a good move. And then you make the change. A lot of work, you got to roll it out to the replicas, but it's very, very powerful. So that's always been a big reason why we've been able to move fast and get things done. So I went there. Yeah, another big thing was around this time, when we started. We tried to put in a construct that we put in place in other places using other database technology and everything, but I don't know if this is an obvious thing. But as I was saying earlier, you sure you got backups, but did you test your backups? Nobody does. If you have a master and 20,000 replicas and you delete a table on the master by accident, I had 20 copies of the table, but I just deleted all 20 copies. So how are you going to recover that? You're going to go to tapes. I don't think so. Exercise maybe now for days. What we did, and maybe a lot of you are already doing, is set an intentional lag, we call it. And all it really does is it stops the SQL thread. It's a little scripting that stops the SQL thread, but lets the IO thread keep going, and keeps that replica a few hours behind or even a day behind. And the theory there is that if the shit hit the fan, well, what do? We go to intentional lag. So we got through the crashes. This is right about when my daughter was born. I have 4 kids. That's the 4th one. Funny thing about 4 kids, it's like I tell people I have 3 kids. They go, "Oh, I got 3 kids, good." And you say you got 4 kids. You got 4 kids. Apparently 4 is the tipping point. Where they start wondering whether I'm Mormon or whatever. But former Catholic. But yeah, so here we are. So around this time, one great boost we got, again, as I say, almost every week, replication back on track, 2-3 second lag, everything's good. We're growing more. Oh, replication's back in the crapper. Constant battle. And one of the things we're trying to do is upgrade 5.0. This is backdrop to all this. There's tons of different plates in the air and things we're not quite sure of, certain bugs we're encountering, and it's hard to aggressively roll out a new piece of software against that backup. So we did, again, power of replication, we were able to sort of slide in some boxes using 5.0, and we did it in a couple different ways because it was really mysterious. We had more than one 5.0 copy out there, and one of them was going really fast. The other guys were lagging. This guy wasn't lagging, and it took a long time to figure it out. Because we were rolling some 5.0s and they weren't fast. It turned out that if you export and import into 5.0, I guess that's my Oracle background stating again, if you MySQL dump and then load back into 5.0, you will get a better performance hit. You'll boost your performance more than if you simply upgrade in place. And the reason is because it can make the rows more compact. It's a compact row format. And what happened? Well, the ones that we did that way, as opposed to the ones we had just upgraded in place by just sort of coming up on a new version of MySQL, they had fatter rows. The guy that was imported or loaded had skinnier rows and had fabulous cache abilities. So yeah, boost from 5.0, just that's the kind of thing that you love. This is probably the longest. They warned me I was going to go long, but I love to hear myself talk. So. This is my, I'll try to get through this fast, but this is probably the most important thing to me to try to tell to somebody what I would wish for them to be able to scale past a certain point. A lot of people with MySQL is they've got a system like on the left, 2 CPUs, some RAM, a couple of disk drives, and when they're dreaming of an upgrade, what they dreaming of? They're dreaming of fast CPUs, right? And they're going to get some big fat disk drives, and to me, that's just exactly the opposite of what you For me, this is what I want. I want lots. If I had money to spend, I would do my best to not even bother to upgrade the CPUs, and I would want to put as much memory on that box as I could. And when I maxed out the memory, so there's a certain balance between wanting a ton of memory and as many spindles as possible. I don't care if they're small, I want lots of spindles. Many of you probably understand what I'm saying, but I just want to drive that point home because I think from what I've seen, a lot of people don't seem to agree with that. I think it's because they don't get the performance out of the box on the right, and I think that the reason is because there's some key tuning things that are missed. So I will try to launch into my philosophy, my aesthetic of what I want a fast system to be. Cache is king. You got to have a big cache. If it's in cache, life is good. But you know, if your database fits in cache, very good. Go have a coffee because you don't need to. When you start doing physical I/O, it doesn't. That's usually, it seems, when when people see their system go straight to hell. It doesn't have to be that way. You have to be able to tune the I/O. There's some counterintuitive things here, perhaps, but my philosophy has grown over the years. It's still true even on MySQL. It's okay to cache writes in all the layers below the database. It is not okay to cache reads. It's not only a waste, it hurts you. And after those 2 points are taken care of, it's very important to make sure that you're truly doing parallel I/Os. If you just go in at night instead of a RAID, it won't happen. What I'm trying to explain about the read caches is, here's a system with the top is a database cache, in my case NODB, like I say, I'm always talking about NODB. And of course Linux caches stuff, which makes me grind my teeth. I wish it just wouldn't cache anything. And typically that's going to be a little bit smaller than the database cache. And then of course RAID controllers, they have cache too, and then that green line is supposed to be your stripe disk below. What happens when you do, this is supposed to illustrate, the database went through and read the first 11 blocks. And because they don't all fit in cache, 0 through 2 have dropped out of the cache, right? And then you look at the file system cache, those blocks all pass through the file system cache too. It's smaller, so 0 through 6 have fallen out of the cache, but it's still caching those last ones for you. And the RAID controller is even smaller. It's dutifully caching things for you because you told it to, but it's caching even less. Well, what happens when you go to read a block that's not in the database cache? Suppose it's 2. Well, 2 isn't in the database cache, so what does it do? It looks in the file system cache. It ain't there either. Why? File system cache is smaller. And usually it can't possibly be as smart as the database cache. It doesn't have enough information to have any better heuristics in the database. Likewise with the RAID cache. RAID cache is even smaller. It's sure not there. So what do? You do a physical I/O because it wasn't in the database cache. What does that mean? The other cache will be useless. Suppose it is in the database cache. Well, you're sure not going to go, if you try to read block 4, it's in the database cache. Again, file system cache useless, RAID cache useless. So my point there is that the read caching is pointless on the layers below the database, but it's worse than pointless. It's actually detrimental. And the reason is because it's always in the presence of writes. So here's an example where you altered some blocks, and those changes were propagated through the lower layers of cache, right? That all happened in less than a millisecond because it's all memory to memory. And now you come along and you want to read a block. Again, it's a cache miss, right? Well, what do you got to do? When the RAID controller wants to read that block, it can't read it, right? Because there's a dirty page in the RAID cache. It's got to retire that block, right? So the read that would have taken, just the normal read time of 5 milliseconds or whatever, it's now taking 10 milliseconds. Why? Because it's serializing behind the writes. And again, they said I was going to run out of time, they were right. So, anyways, my point here, takeaway, the lesson learned, do not cache reads in the file system. Do not cache reads in the RAID controller. And I think that might be part of the reason why people don't think they get the performance out of these boxes with a lot of drives. It's the mistakes that you make like that make this box with lots of disk drives act like it's just one disk drive. So, anyways, it gets even better because as long as you're using direct I/O and bypassing the file system cache, you can see here that there's a couple of writes and a couple of reads all going on at the same time. Whereas these systems with just 1 or 2 disk drives, or systems that have a lot of disk drives, but weren't tuned properly, are getting just 1 at a time. The last part about making sure that you get parallel I/Os, it's a common misconception that people think that yeah, I'm going to get my stripe going, and I'm going to make sure that all the disks are firing when I do a read. So I'm going to stripe it, and when the database does a 16K block read, it's going to fire up all those disks and send me the block. That's wrong, because now it's 1. Well, suppose you do 3 successive 16K reads, and you stripe it across all the disk drives. What does it have to do? It has to seek all those drives. It has to find the 2K little bit of the 16K block and then deliver all those 2K bits. Then there's the next one. Does all that again. It seeks again. There's another 5 milliseconds. Gets all the blocks together. Gives you the 16K block. Third read, same thing. What happened? It took you 15 milliseconds to do 3 reads. Well, if you had a big fat chunk size, such that your 16K block exists on just one of those drives, and it's kind of random where it's going to go to, here's 3 reads. Well, there's a good chance that those 3 random reads wound up going to 3 different disk drives. They all seek at the same time. They all deliver the block at the same time. Those 3 reads 3 times faster. You're getting more throughput. Don't configure your RAID controller like that. So, I can't get through this. Another thing, to my chagrin, I found that I was gnashing my teeth for a long time early on, and I found it was still serializing, even though I knew I was doing all the right things. It's a very long story, but I call this mystery serialization. Here's my summary of the things to do to try to avoid those problems using O-Direct and certain Linux kernel settings, although it's always squirrely, to try to get to not cache anything and read cache. Some of my slides are a little incomplete. You can do these things on LSI and AdaptTech. I was never able to find the proper settings on freeware. I don't think they exist. Make sure you set the stripe right. But then a certain thing called mystery serialization was happening. I never really figured out why. I tried many permutations of file systems, many different things. It still does not make sense to me. If anybody wants to talk about it, like, great, we won't do it here. But the way you can tell is if your disk drive is at 100% busy, but when you add up the number of IOs it's doing, you can tell for sure that it's not doing the IOs concurrently. Here's a little illustration of the example. Both of these, this is supposed to be 4 disk drives. They're serving random reads. Here at the top, they're actually happening in parallel. And when you look at IOStat, what you will see is, because there's a gap here where nothing is happening, those 4 disks, IOStat will show that stripe, it shows up as just one drive to Linux because you striped it and presented it as a single drive to Linux. It will show up as 80% busy. You're doing, these 9 IOs in that. But another RAID set up without these options, it's going to show 80% busy, but it's only doing 4 IOs, and that's the amount of time. You can see that here's a part where this entire stripe is idle. I'm still not sure why, but the way I fixed it was to mirror disk drives and hardware, stripe them in software. I suspect this might be another reason why people in the MySQL world, they get these RAID controllers and are very disappointed at what happens. I still don't understand why that's true, but that's what I had to do to get the throughput out of the array that I knew it was capable of. So we're back. Replication is now fast again, and we're still growing. And all this time we knew we had to do something better than replication. We had to really do a proper horizontal scalability. All the reads are going to the master. We're starting to run out of bandwidth on the master. Lots of upgrades. But we know what we really got to do is get to this place. A guy, Mike Solomon, went to the mountain. He kept fighting the fires. Went to the coffee house 2 weeks later. Came back with a refactored database later. We got it rolled out with just one machine, right? So he set it up so that we could have multiple masters. But how do you test this? How do you know it's going to work? How do you know you're not going to corrupt data? How do you move the users in the first place? You got this one master database with all your users on it. How do you split that database in the first place to start serving to? It's non-trivial. There's a lot of data. You might screw it up. You might corrupt it. Anyways, we did get the code rolled out with, so we were testing all the code paths, and it was working. But there were so many other things that we didn't have taken care of. That was right about when the Google deal happened. We were afraid to roll. We were afraid to do some of these things to sort of screw up all the good things that we had. Had to scale replication farther. Yeah, so I guess I'm never going to I won't be able to, they were right, it took too long. I'll never be able to tell you the beautiful war stories that happened when we just finished rolling that last week, which is when I should have been doing this presentation. Well, I guess I should. Me and many other people, Santosh and San Antonio, they're probably out there somewhere. We all worked really hard. Happy to say we did get the horizontal scalability done. One thing I probably should talk about is one thing that of course is that's I got a lot more lines, a lot more little adventures we had trying to get to this point, which is today, and that's literally 5 days ago we finished rolling out. We sort of built a bomb and it worked. And that's what we call EMD, which is our code name for our horizontal scalability solution. It stands for even more databases. Or alternatively, it stands for extreme makeover database. But anyways, I should talk about this one thing. One of the big things that got us from this point I'm describing here, right about the time of the Google deal, and when we kind of chickened out running EMD to the end, was I was trying to get replication again in the tank, even though we had done all these rate tuning things and rolled out even more replicas. It's back to replication lagging a lot. What I tried to do, replication of course has to do things serially that were done in parallel on the master. That is why replication is slower. You can do the same updates on the master, put the same things with hardware out there, same tuning settings and everything. It's way slower on the slate. Why? Because they have to happen sequentially. They can't happen in parallel like they were happening in the master. The master can do the updates in parallel, and only the commits, the very last step, is serialized. Basically, a big part of what's happening there is doing the I/O takes a long time. That's the purple, whatever color that is supposed to be illustrated. And the gray part is the time it takes to do all the CPU stuff. If you can get things to be in cache, it's only going to take that long when you get cache. Everybody knows it, right? Well, there's a thing called the Oracle caching algorithm, and that's not Oracle, the software. In academia, there's a thing called an Oracle where it means you can predict the future, and you know what you need to have in cache in the future. And so it is useful as a benchmark to test your caching algorithm to see if you've done something perfectly. This is the perfect caching algorithm. You can predict the future so you know what to put into cache. I was sitting around trying to make replication go faster. That's pretty much what I've been doing for the last 8 months. And I started sort of manually caching tables by doing selects from them. And short story long, it dawned on me that when you're sitting there on the replica and it's reading from the queue of events that it has to play back, it's down here at the bottom playing some whatever random update it has to do, but you do know the future. You already have queued up all the things that it's going to do next and next and next, and it's doing them serially. So what I did is I wrote a script that went through that very same log, read all those update statements, did some trivial regexes to them, turned them into selects, and did the selects. And guess what? Replication got 3 or 4 times faster. Why? Because now it's always getting cache hits. You have the Oracle caching algorithm implemented. So that was one of the big things. I've asked these guys to implement it, and crap. I didn't get to talk about the diamond. The diamond was a beautiful thing. That's how we figured out how to actually split this now very bloated database. Again, using replication. What we did is we wrote this. I wrote a tool to split it initially, but of course when you do the split, it's going to take you 6, 8, 10 hours to just split that database, to separate the users on different databases. It's going to take 10 hours, right? You can't take 10 hours of downtime. So what we did was we wrote some code, Mike Solomon wrote some code to parse the bin log, detect which shard the user should belong to, and what we actually started doing is, we did the 8-hour split with the 4 databases, and started running his code to then read the bin logs and start replicating, demultiplexing the replication to those 4 shards. And I'm happy to say it all worked, because by the time we really needed it by that time, by the time we finished it, we were seeing hours and hours of lag. And once again in our history, we weren't even sure the replicas were going to catch up overnight, and the users were just about giving up on us. And it was a great piece of work by Mike, and hundreds and hundreds of times we created new replicas and iterated. A couple guys in the audience, Jonathan and such. So didn't pace myself quite right, but hey, I guess my time is up. Love to talk about some of this stuff more. Maybe we'll get a chance.